Welcome back to Chapter 3. In this chapter, we are going to continue working on lines. We'll work with the equations of lines, but we're going to do more with them. We're going to see some applications. We're going to look at something called functions and deal with linear functions. We're going to see arithmetic sequences, scatter plots, and lines of best fit. So it's still working with lines. It's just a little bit more. It's a different look at lines. This section specifically, we're going to be talking about relations and functions. In this section, there's little like math. Like there's little calculations and stuff like that. Most of what we're going to look at in this section is going to be more definition, and you're going to be able to see stuff by observation, just by looking at it. What is the answer going to be? So this section's a bit different than the ones that we've been working on, which might be nice for some of you. It might be not nice for some of you, but it is a little bit different. In the next section, we'll get back to working with more equations. So here we're going to be looking at relations and functions. Our learning targets for today, I can determine whether a relation is a function. And so for this, the very first thing we probably want to look at is, what is a relation? A relation is just a set of ordered pairs. I've seen it described as a mapping from one variable to another, which does not help at all with the definition. But it's a set of ordered pairs. We'll see them in a few different ways. We'll see them as tables. We have x and y a lot of times. Maybe x is 0, 1, 2, 3, and y is 5, 6, 6, 7. That is a relation. That's a set of ordered pairs. It could just be ordered pairs, like blank comma blank, blank comma blank, blank comma blank, like 0 comma 5, 1 comma 6, 2 comma 6, 3 comma 7. It could be like that. We can have what's called a mapping diagram. A lot of times, or not a lot of times, but you will see mapping diagrams in the topic today. And a mapping diagram, I'm going to do the same one. So we'll have x and y. X was 0, 1, 2, 3. Y was 5, 6, or 7. And then just 0 went to 5, 1 went to 6, 2 went to 6, and a 3 went to 7. That's a mapping diagram. That shows the exact same thing as this table. And while we're talking about it, may as well write down some ordered pairs. We had 0 comma 5, 1 comma 6, 2 comma 6, 3 comma 7. So these are all describing the same thing. We could even graph it too. That's another way we can see a relation. And so we had 0 comma 5, 1 comma 6, 2 comma 6, and 3 comma 7. All right, so those all show the exact same thing. That's the exact same relation. I have 4 points simply because I didn't want to have any more. It could be a lot of points. It could be just a couple points. It doesn't matter. It could be more than just points. So, but that's what a relation is. Now, a function is a special kind of relation where each input goes to exactly one output. Generally speaking, the inputs are the x variables and the outputs are the y variables. Now, that's not completely universal. We could be talking about the money you make based on the time that you work. The input would be the time, and the money would be the output. So we'd have time and money, or maybe T and M. So it's not always X and Y, but kind of the general sense is X and Y. So this says that each input goes to exactly one output. So each x value has exactly one y value associated with it. The relation that I have up here is a function because each x value goes to exactly one y value. Now, there is that 1 goes to 6 and 2 goes to 6. They go to the same y value, but that's okay. If we have an input of 1, we know what we're going to get. We're going to get a 6. If we have an input of 2, we know what we're going to get. Um, the analogy I like to use for a function is a soda machine. So in a soda machine, and this is the perfect soda machine because it's always loaded correctly and you don't have to put any money in. You just have to push a button and you get your soda or pop or soda pop, or if you guys don't know what soda is because we don't have it on campus, it could be a water machine. We get flavored water. But we have several buttons. Usually they would be kind of in a column, but this is one that has those big buttons. And we have button 1, button 2, button 3, button 4, button 5, and button 6. So button 1 is going to give us Pepsi because, well, as we can see, it's a Pepsi machine. Button 2 is also going to give us Pepsi. Because, I mean, on Pepsi machines, there's always two kinds of Pepsi, or two buttons for Pepsi. Same with on Coke machines. There's two buttons for Coke. Button 3 will give us a diet. Button 4 will give us a Sprite or Sierra Mist. Button 5 will give us the good Dr. Pepper. And button 6, I'm going to reserve this button for myself. This will give us a Baja Blast. I told you it was the perfect soda machine. I can get Baja Blast at the push of a button. It's a beautiful thing. So, this is a function because every button I push, I know exactly what I'm going to get. If I push the 3 button, I'm going to get a diet. If I push the 1 button, I'm going to get a Pepsi. If I push the 2 button, I'm going to get a Pepsi. That's okay. I can get the same thing from a couple different buttons. What would make this not a function is if there was a button where sometimes I pushed it and I got a Baja Blast. Sometimes when I pushed it, I got a diet. How upsetting would that be? So that would make it not a function if there's like a random button where you'd get something and you don't know what it is. It is a function because for whatever button you push, you know exactly what you're going to get. A water machine is a function where it has just water. There's 7 different buttons to give you water. It's a function because when you push a button, you know what you're going to get. You're going to get water. It doesn't matter what button you push, you're still going to get water. That would be the equivalent of a horizontal line, by the way. But that is a function. So one of the things you're going to do today is you're going to be differentiating between is it a function, is it not a function? But we do have some more vocab coming up here. We have the domain. The domain is the set of all inputs. So it would be the x values. The domain of our initial set, the one where we have the mapping diagram and stuff, we would probably write that using roster notation. Roster notation is where we put the squiggly bracket, and then we just list 0, 1, 2, and 3. Those are the possible inputs we could have. For our soda machine, our domain would be the buttons. We had button 1, 2, 3, 4, 5, and 6. That would be our domain. because those are the inputs. Those are the things I could press. Now, the outputs, that's called the range. The range is a set of all outputs. So in our initial one, so our domain is this bubble that has where the arrows start. The range is that bubble, which has where the arrows end up. So our range, we would do it the same way here, roster notation. I'll show you other ways when we'll see some other things on another slide. But we're going to list the things. We had 5, 6, and 7. Notice I did not have to list 6 twice. Same thing down here, our range. We could have Pepsi. We could have a Diet. We could have a Sprite. We could have a Dr. Pepper. Or we could have a Baja Blast. I didn't have to list Pepsi twice. It doesn't matter which button I push to get the Pepsi. It's still the same thing. It's a Pepsi. It's not like, well, this is a button 1 Pepsi and a button 2 Pepsi. I mean, we're not talking like left Twix and right Twix here. It's the same thing. So we only list it once. Continuous. A continuous function is a function that has all things in the interval. So the things that we've been dealing with earlier with like lines, those have been continuous. Now, it's continuous versus something that is discrete. Discrete stuff is what we've been looking at right here. X could equal 0, 1, 2, or 3. It can't equal 1.5 in this situation. The graph of something that's discrete looks like this, where we just have some points. The soda machine is definitely a discrete function because there are 6 buttons. You're not going to push the 1.5 button. You're not going to push the 3.78 button. You can push button 3, you can push button 4. Those are the options. And then what you get out a Pepsi, a Diet, a Sprite, a Dr. Pepper, a Baja Blast. You're not going to get out some mix of something in between there. And so with discrete, we just have points. When we're dealing with the continuous functions, the continuous relations, we're going to have more of like actual connected lines. And we're going to see those some on the next slide where I have a little bit more room. But the discrete stuff, that's when we do our domain and our range like this using roster notation, where we can just list the possibilities. Like you don't want to list every possible number in between 1 and 2. There's an infinite number there. So listing them wouldn't work. So we're going to have other methods of doing that. And then one-to-one. This is our last vocab word, and we're going to just see some examples here. One-to-one is where it's a function where each output comes from exactly one input. Our 2 functions that we're looking at are not one-to-one because the first one, 6, came from both 1 and 2. In our soda machine, Pepsi came from 1 and 2. So those aren't one-to-one. So a function says that when we push that button, we know what's coming out. If it's one-to-one, that means that if we see what came out, we know exactly what button was pushed. So let's take a look at a couple more examples here. So let's take a look at a continuous function, a continuous anything. So if we have a continuous, it could look something like that, where it's connected. Now this isn't a line. That's okay. It doesn't have to be a line. when we look at our x values, does each x value go to exactly one y value? The answer there is yes, it does. If we have this x value, it will give us about that y value. There's not more than one. We do have a method of when we're looking at the graphs, we have a test to test to see whether it's a function. That test is called the vertical line test. And what that says is if you can draw a vertical line through any place, like through every place, and hit the graph in only one place, then it's a function. If it touches the graph more than once, it's not a function. So this one would be a function. It is not one-to-one because if we're just looking at this y value, we have it here and here, which is going to go to two separate x values. So it is a function. It is not one-to-one. The domain for something like this is all real numbers because we can assume that it keeps going. So the domain is all real numbers. We have a symbol for that. The symbol for that is called a blackboard bold R. And we have a symbol for it because we write it a lot, and math people are very lazy. And lazy, when I refer to it with math people, is just a very efficient way of saying efficient. We don't want to write out all real numbers every time. So we have this blackboard bold R that means all real numbers. That's the only time it's ever used. The range, well, we don't have all the numbers because it stops. Wow, that don't know why that pen started over there, but it did. Look at that. It stops here. It stops at 0, and then it goes back up again. So the range is going to be all the positive numbers. Well, we don't want to write all the positive numbers. We don't want to write them all out like we did in roster notation. And so we can use an inequality. We want y to be greater than or equal to 0. That's the range. We could do the same thing for x. Perhaps we have a line segment that goes from here to here. Is this a function? Well, does every x value go to exactly one y value? Yes. Yes, they do. If we know the x value, we know exactly one y value that it can go to. Does every y value come from exactly one x value? Also yes, because it doesn't curve back on itself. And so this is both a function and it's one-to-one. And then the domain, what could x be? Well, x goes from 0 to 3. So it'll be less than 0 and less than 3, or greater than 0 and less than 3. The range, y, goes from 1 to 3. So 1 is less than or equal to y is less than or equal to 3. So that's how we would write it out if it was continuous. Now, what does something that's not a function look like? I mean, we've had a lot of things that are functions. If I wanted to make some graphs of things that are not functions, we could have something like a circle. A circle is not a function because if we take an x value, say this x value right here, we're going to get two different points for that x value. So that means this is not a function. Now, that doesn't mean it's a bad thing or anything. It's just functions are special relations that we can do certain things with. This one is not. Has a lot of uses. It even has a name. It's a circle. Another thing that could be not a function is the curve that comes like that. Again, if we take an x value, we get two y values for it. Not a function. If we wanted a discrete relation that was not a function, we could put some points and this is not a function because this x value has two y values associated with it. So it's not a function. If we were looking at that in a table, what this would look like, we had x was 1, y was 1, x was 1, y was 2, x was 2, y was 3, x was 3, y was 0. The thing to notice in a table is the x value repeats itself, and then it goes to different things. If we had 1, 1, and then another 1, 1, then that would still be a function because it's going to the same thing. It's just repeated the point, which is kind of silly, but not disqualifying. If we were looking at a mapping diagram of this, we'd have 1, 2, 3, and then 0, 1, 2, 3. So 1 would go to 1, 1 would also go to 2, 2 would go to 3, and 3 would go to 0. So the thing to notice here is that we have those two arrows coming out of 1. Tells us it's not going to be a function. It can still have a domain and range. The domain is 1, 2, 3. The range is 0, 1, 2, 3. So it can still have all that stuff. It's just not a function. And so that's one of the big things that you're looking at today is it a function? Is it not a function? So it's a purely uh, definition type thing. There's no work really to go into it. You're just looking, is it a function? Is it not a function? This is not a function because 1 goes to 1 and 1 goes to 2. You'll also be finding the domain range, seeing is it continuous or discrete, and determining if it is a function, is it also 1 to 1? So does each x value go to exactly one y value? And does each y value come from exactly one x value? So that's the first section here. Again, there's not a lot of like what we'd consider math in here. It's definition and just like looking at things and picking out the pieces that we're looking at. So I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.